Good morning, everyone. So we are ready to start with the first speaker of the day. And it's my pleasure to introduce Professor Lino Nobili from Hospital Gaslini in Genova. And one of the research topics of Professor Nobili is related to the study of drug-resistant epilepsy and application of source modeling to detect epileptogenic zone. And in his talk, Professor Nobili will provide an overview on presurgical multimodal assessment of focal drug-resistant epilepsy. So please, Lino, I leave the floor to you. Thanks.
Thank you, Annalisa. Thank you, everybody. Thank you, Alberto, for inviting me. I have to say I'm a little bit embarrassed. I'm a clinician, a child neuropsychiatrist and clinical neurophysiologist. Okay, so try to repeat what I did before. It's not working. Sorry. So open reader. I start from here. Okay. So I think now you should see my screen.
Yes, we see.
Right?
Yes, it's okay.
Okay, so now you see my screen. It's okay?
Yes, it's okay.
I would like to do what I did before, but for some reason I'm not more able to do. Okay, doesn't matter. Well, do you see my screen now, right?
Yes,
or
yeah, it's okay.
It's okay. So, well, yes, I will give you an overview. As I told you, I'm a little bit embarrassed because I'm a clinician. But however, since my beginning of my activity as a physician, I was used to work together with physicists, mathematician, engineer, probably because since the beginning I've been working with EEG, so spectral analysis and Fourier transform was something also very usual for me, but indeed I'm not at all a mathematician. And I thanks a lot all the friends that I have around that are physicists and mathematicians that every day they help us in improve our clinical work. So I'm just going to present you the overview of the presurgical multimodal assessment of focal drug-resistant epilepsy. So first of all, a couple of words related to seizure and epilepsy. Well, we know that an epileptic seizure is a transient occurrence of signs or symptoms due to abnormal, excessive, or synchronous neural activity in the brain. It's not clear what's really happened. It's really a synchronization, or there are many aspects that can help understanding what's happened during a seizure. However, the seizure is different from epilepsy. Indeed, everyone in certain conditions can have also a seizure. Fortunately, it's very rare. However, epilepsy is a disease when seizures repeat themselves over time. So it's characterized by an enduring predisposition to generate epileptic seizure, and also by the neurobiological, cognitive, psychological, and social consequences of this condition. Just a very schematic representation of what is focal and generalized, what are focal and generalized seizure. Focal seizure is a seizure that starts from a restricted region of the brain and can also spread only in a very limited space, so can, for example, remain within the temporal lobe, for example. Then a focal seizure can present a secondary generalization. That means that the epileptic discharges starting from the temporal lobe can involve subcortical and cortical structure, and so producing a generalized manifestation. And in general, it took some seconds from the onset at the focal level and the secondary generalization. A generalized seizure is something that immediately started involving all the brain. Although we know that there is probably a focal onset, the involvement of the other structure of the brain is immediate, so it can take milliseconds. So clinically, it's a generalized seizure. So we speak about focal. Today we will speak about focal epilepsy because surgical approach is, at least if we speak about curative surgical approach, therapeutical one is almost dedicated to focal epileptic manifestation. We can have also some approach, surgical approach for generalized, but only as in this case, this kind of treatment have more a palliative effect. And we know also that epilepsy, that is very, very frequent disorder, is also characterized by the fact that a high percentage of subjects suffer from drug-resistant epilepsy. It means that there is a failure of adequate trials of two tolerated and appropriately chosen anti-epileptic drugs. So what we know that if we have tried two drugs, the one that are really appropriate for that epileptic manifestation, and this drug that do not work, is very, the probability to find a third drug that can be effective in the treatment is very low. And the percentage of subjects that are affected by focal drug-resistant epilepsies is about 30 to 40% of the population that have been described. So a relevant percentage of subjects affected by epilepsy are drug-resistant. It has been shown demonstrating in the last years, and for example, this is a relatively recent paper published on the New England Journal of Medicine, that surgery for drug-resistant epilepsy, both in adults and in children, is strongly recommended with respect to anti-epileptic treatment for focal drug-resistant epilepsy. Indeed, in this paper, it has been shown that children is a randomized study, so it's almost impossible to conduct a randomized study now in Europe on epilepsy surgery because it's so obvious that surgery is working. However, in this study, the authors were able to conduct a randomized investigation, and they were able to show that children and adolescents with drug-resistant epilepsy who had undergone epilepsy surgery had a significantly higher rate of freedom from seizure and also a better score with respect to behavior, quality of life, than did those who continued anti-epileptic treatments. And the difference is extremely evident. This has been demonstrated in both in children and in adults. At the basis of focal drug-resistant epilepsy, we have different histopathological substrates. It's important to underline that finding a lesion within the brain does not mean that we have individualized also the region where the epileptic seizure starts. I mean, we need always to find a correlation between a possible lesion within the brain and the clinical aspect of the patients. Indeed, it's also important to underline that there are, especially in children, where a cortical malformation are the mostly frequently histopathological substrate, sometimes cannot be clearly localized on MRI, on structural investigation. So we can have a patient with a clear focal drug-resistant epilepsy, but with an MRI that is uninformative. And sometimes we can also have, as we will see, EG that is not electroencephalogram, scalp EG that is not so informative. Epilepsy surgery is indicated and can achieve also a very high percentage of seizure freedom. If you look at this graph, you can see that, for example, for subjects that have the duration of the disease less than 15 years, we have a rate of seizure freedom that is about 80%. Class 1 is a classification, meaning that if you are in class 1, you don't have any more seizure. And you see that the rate of success with epilepsy surgery is high, although is a little bit lower if we wait too much. So it means that the duration of the disease is something that play a negative role on the possibility to be seizure-free after the intervention. However, as you can see, the percentage of seizure freedom is very high, and considering also the possible neurological morbidity that is less than 2% and mortality that is very low, this means that epilepsy surgery is really something that must be considered when approaching a patient with focal drug-resistant epilepsy. Unfortunately, there is still, I would say, many neurologists, many specialists also in the field are not so convinced of the usefulness, and they always think much more about the possible complication. However, living with epilepsy is a very difficult thing, and we will see that it's not only the impact that related to seizure. Another important aspect that we have to consider is that not only we achieve seizure freedom with high level of probability if we perform surgery in the early life, but also we reduce the risk of complication after the surgery-related complication. In the study, we show that increasing age at surgery, also during the pediatric age, was associated with an increase in odds of developing severe surgery-related complication. As you can see also in this study, the percentage of seizure-free subject was relatively high. About 75% of patients are in class 1, so it means they are seizure-free. As I told you before, seizure and the epilepsy in general has a very negative impact on cognitive and psychological function of the subject. This can be a consequence of the etiology per se, or could be a consequence of seizure, of also interictal activity can be correlated with cognitive alteration, and also anti-epileptic drugs, especially when you have a patient with drug-resistant epilepsies that taking more than 1 or 2 or 3 drugs. Moreover, it's not only a problem of cognition, it's also a problem related to the social life, especially in children. So epilepsy became a problem at the level of the family, organization of the family, at the level of playtime, sport, and school, and so on. So this means that epilepsy surgery in children, something that must be conducted as soon as possible, and say the sooner is the better. Well, let's now enter into the protocol of investigating a subject affected by drug-resistant epilepsy. Well, we have to individualize the epileptogenic zone, so where seizure starts, and then we will see the definition of the epileptogenic zone. In order to individualize the epileptogenic zone, there is a continuum interaction between different experts. Here I've written only the neurophysiologist, child neurologist, but we have also neuropsychologists, neuroradiologists, and so on. However, there is a strong interaction between the epileptologist and neurosurgeon with the aim of individuating. Excuse me, there is someone with the microphone that is open. I hear a noise in my, thank you. So, the objective is to individuate the epileptogenic zone and to plan the surgical intervention. And in order to design, to achieve a surgical plan, we need to be sure about the location of the epileptogenic zone. And in order to create a condition that allow the patient to be seizure-free from after intervention, but also without any deficit. That means motor or cognitive deficit. So a kind of investigation where many actors play together in order to individualize, localize the epileptogenic zone. So the epileptogenic zone is considered the minimum amount of cortex that must be resected or inactivated or disconnected. Now we have many procedures in order to produce seizure freedom. Here you see a kind of protocol when you see the patient, drug-resistant patient that arrived in the lab, and then after the clinical interview, when we collect all the clinical symptom manifestation, the clinical history, there are a series of neurophysiological and neuroradiological and functional investigation that in general are conducted during the presurgical evaluation. So we can have electrophysiological, EEG, video EEG, neuroradiology, high-density EEG, position emission tomography, Fmri, MEG, neuropsychological investigation, also psychiatric evaluation. So after this investigation, we can be able to localize the epileptogenic zone, and so we can send the patient to the surgical intervention. Or, unfortunately, sometimes we are not able to really localize the epileptogenic zone, and then we need invasive investigation. Invasive investigations are indeed mandatory when all the presurgical assessment with non-invasive protocol, from EEG to all the functional and neuroradiological techniques that we have, including source analysis. When we are not able to individualize the epileptogenic zone, when the signs or symptoms are not in agreement with the neuroradiological findings or with the EEG findings, or we are able to localize, for example, an hemisphere, but not the lobe, for example, or a peculiar part of the lobe, or when there is a suggestion of a precocious diffusion in wide areas. In these cases, when video EEG doesn't resolve the doubtful points, patients can be submitted to invasive electrophysiological recording. In particular, I'm used to work with the stereo EEG, but we have also other methods like corticography, although stereo EEG now is more and more also adopted by, for example, in the USA, where before they were used to adopt the corticography. Now stereo EEG is extremely developed also in the USA. So I was saying that we are a kind of investigator. So we are trying to collect all the information that can be useful for localizing the epileptogenic zone. For example, when we interview the patient, we ask for some subjective manifestation. So we ask for, do you have a visual illusion before the seizure? For example, the patient can say to us, I noticed that they have some jerks on my end, but before these jerks, I have also a kind of visual hallucination that is also projected in my left side. So in this case, if we have visual illusion or hallucination, immediately we think that could be that something is originating from the occipital region, from the calcarine, or from the more associative visual region. Again, if we have manifestation like auditory hallucination, we know that the acoustic area is located within the superior temporal first circumvolution, so we can think that the seizure can start from this region, and so on. We have many clinical manifestations that immediately for us is a very, very important information in order to try to localize the onset, or at least the region that is most involved by the seizure. Like, for example, rising epigastric aura is a typical subjective manifestation that can refer a patient affected by temporal lobe, in particular by mesial temporal lobe epilepsy. This is something that the patient can say to us. However, also other people that have seen more than one seizure can also give us very important information in order to interpret the signs and symptoms of the patient. What we have in mind as a neurophysiologist, clinical neurophysiology and clinician, is that, however, the epileptic discharges within the brain move inside a space. So we have the three dimension of the space of the brain, but then we have also the fourth dimension, that is time. So there is an epileptic discharges starting one side of the brain and then moving inside the brain and touching different region during the time. And so we are used to try to interpret the clinical manifestation having this in mind. So, for example, imagine that we have a seizure starting from one region of the brain and immediately involving another very close anatomical region. And here we have the first clinical manifestation. The first clinical manifestation is probably related to the activation of the first region. Then the epileptic discharges over time involve a second cerebral structure. At this time, we can have a second clinical sign, and this clinical sign can be a little bit mixed up with the first one. And then again, the discharge involve another structure and so on. So the seizure semiology depends on which are the structures that are involved at that time. The effect of the epileptic discharge is a kind of excitatory or inhibiting the function of that structure and so on. So we have at the end a clinical, general clinical manifestation that is induced by the fact that epileptic discharges is moving within the brain, touching different cortical areas. And in our mind, we have this scheme in order to try to understand where seizures can start and when seizure can spread. Then we use, this is something that we do interpreting clinical, simply interpreting the anamnestic aspect of the patient, but then we can also go in deep and analyze the seizure using, for example, video EEG recordings. I mean, the simultaneous recording of EEG together with the behavior of the patient. So electroencephalogram is an instrument that is extremely important for the investigation of patients, because it can give information related to interictal spike. In this case, for example, we have some interictal spike over the temporal region in this patient. Consider that sometimes it is important to conduct a recording during sleep, because only during sleep we can see sometimes discharges, while during wakefulness these are not so evident. And then we record also a seizure, and we try to see if what we have recorded during video EEG is also something that is correct with respect with the anamnestic data collection that we have performed. Then we use neuroradiology. So we have an hypothesis. We think that there is a kind of an onset in a particular region, and then we ask for a neurological investigation, keeping in mind that we have an hypothesis. Although so we discussed that this would be something that we should have this kind of information with data-driven approach, but sometimes we cannot find a lesion within the brain if we don't have an hypothesis, if we don't know where to search for. So, and now neuroradiology is improving more and more, because we start with 1.5 Tesla, now we have 3 Tesla, and we have also the possibility to submit patients to 7 Tesla. And as you can see here, here you have a very, very small focal cortical dysplasia that could not be detected with a 1.5 Tesla, or can be very difficult to recognize. So we have sophisticated instrument, although this sophisticated instrument must be guided by clinical hypothesis. And then we can use many other analysis of the brain MRI. For example, we can even also evaluate the cortical thickness with different methods. And again, this can be an instrument that can be useful together with the classic MRI protocol. More and more we use other techniques. For example, using MRI, now we are able, with the technique that is more morphological, to have also functional data related to the cerebral blood flow. In particular, this technique, arterial spin labeling, is something that we use more and more, especially in children, because it can give very important information related to the possible location of the epileptogenic zone. Indeed, we know that, for example, if we perform an MRI investigation immediately after a seizure, we can have an increase of cerebral blood flow in the region that has been involved by the seizure. And so we can have a clear and important information for localizing the brain region that is involved in the seizure onset. If we perform the same investigation, not during the ictal phase, but during the interictal state, we can have the opposite effect. So we can have a kind of hypoperfusion of the region, like we can see in other. This was ictal, sorry, and here was post-ictal. You can see during the interictal phase that we can have hypometabolism. So again, this is an exam, especially for children, is not invasive. It can be extremely useful, another exam to put together with all the other. And then we have position emission tomography. This is a nuclear medicine. And again, we know that if you perform, for example, in case of focal cortical dysplasia, the dysplasia is general in the interictal state is hypometabolic. So again, this is an exam that can be extremely useful. Here, clearly is invasive, especially for children. And then that's why working with the mathematician, physicist, and engineer, we are trying to see with quantifying method is, for example, this method of arterial spin labeling that is not invasive, because we perform this one during the MRI recording, can give the same information of a position emission tomography study, where indeed we need to inject a nuclear substance into the blood of a child. So then what is extremely important is also to localize and lateralize functional areas. So in this case, it's extremely useful the protocol that included task-based Fmri investigation, where we can look in at the localization of the motor region. We can look at the localization of the Wernicke region, or the language areas, or Broca, like in this case. And this is extremely important when you need to plan a surgical intervention, to clearly recognize the limits of the lesion with respect to the functional area, like, for example, in this case, where you can visualize clearly the pyramidal tract, the lesion, and the location of the motor area. So this is extremely useful, especially now that in the surgical theater, the neurosurgeon is working with the robot, and is really seeing during the intervention where he is second by second looking at the MRI data. So it's important also all this process of post-processing analysis in order to prepare a surgical plan. Now I show just an example of what does it mean video EEG. Here, for example, we have, in this case, it's an adult patient, because it's more easy to show, is performing a video EEG recording. So in this case, the patient is probably pushing a button because he's saying I have my typical sensation that is arriving, an epigastric sensation. Then he's able to speak with the technician, and is able to speak correctly, to answer correctly. After some second, however, is stop speaking, is not able to understand. And after the seizure, so, and after the seizure, the patient is saying that he remember that he called the technician. That probably the technician asked also him something, but is not aware of all the things that happens during the seizure. So we have a patient with an epigastric manifestation, able to speak for some seconds. You have not seen because the video does not allow. However, there are some oroalimentary automatisms that are typical of a temporal lobe seizures. So in this case, we have this video EEG. The video EEG, the ictal video EEG, is showing to us that during the manifestation, you can see here this rhythmic theta activity that is evident only on the left frontotemporal derivation, and also here, however, on the left. And then, so we have an hypothesis. It seems that the subjective manifestations are typical of a temporal lobe epilepsy. E.g., interictal and dictal is clearly localized within the temporal lobe, in the left temporal lobe. We perform MRI. We see that there is a left hippocampal sclerosis. This patient has been operated for a temporal lobectomy. The patient is seizure-free, stopped the drugs, and without any cognitive alteration. So in this case, it's very simple. All the anatomo-electroclinical features correlate perfectly. The subjective manifestation correlate with the EEG, both the interictal and ictal, and also MRI is perfectly coherent with the anamnestic and the electrophysiological data. This is a case where we go directly to the intervention. However, there are many times that we are not so lucky. So we can have clear symptoms, we can have clear epileptic discharges, but for example, the magnetic resonance imaging studies is not so informative. So we are not able to localize a lesion within the brain. If you look at this graph, well, it's very standard one, so showing that EEG, electrophysiological investigation, have a very high temporal resolution, but with respect to other morphological exam where the temporal resolution is reduced, although the spatial resolution is increased. And now, however, we have something more for EEG. Alberto was speaking about this at the beginning. I mean, we can have also electrical source imaging that can move the electrophysiological exam to a kind of neuroimaging information that we can have, because we move from the electrophysiological spike or epileptic discharges to also an exam able to localize this activity within the brain. So you are the expert on this point. So we work with this, we have spike on the surface, we recorded the spikes with the EEG, and now we can have high density EEG, so we can increase the resolution of the sensor that are positioned on the scalp, and we can apply source modeling techniques in order to localize the epilepticogenic zone. So we can apply this to interictal, but there are also some application to ictal EEG. And this can be extremely useful in our clinical practice. For example, this is a patient, 15 years old patient affected by drug-resistant epilepsy with very frequent seizure. And we perform an MRI recording that was uninformative. Clearly, we had a suspicion of the left frontal origin of the seizure, and also the electroencephalogram was showing clear-cut epileptic discharges. Also, the characteristic of these discharges remind us the possibility that underneath there is a focal cortical dysplasia. And so, in this case, focal cortical dysplasia is extremely localized, can be very small, and can be, as I told you at the beginning, not visible on MRI. So this is really one of the best examples where electrical source imaging can be useful in clinical practice. So we perform electrical source imaging. In this case, I think we use two different methods. In this case, it's music, and here we use the Loretta. And we localize perfectly, very in a similar way with the two methods, a region within the brain. Then we submitted this patient to a 7 Tesla MRI, and we take care particularly of this region in order to see if we could detect something here in this region. And with 7 Tesla, indeed, we were able then to localize a lesion, a possible lesion on at the bottom of the sulcus. And this possible dysplasia was also correlated, here you see the localization of the dipole, with the hypometabolism detected by PET or by arterial spin labeling techniques. The patient then performed an fMRI investigation for motor function and language function. You see here the multimodal representation of both the localization of the dipole with music, or Loretta, I don't remember, and also the activation of the language area. The patient was then directly submitted to the intervention, and just at the bottom of this sulcus with corticography, we were able to detect epileptic activity that immediately after the removal of the part that was located at the bottom of the sulcus, e.g. the EG close to this region was immediately clean. So the patient, we were able to see that it was a type 2 focal cortical dysplasia, a typical anatomopathological substrate, and the patient is seizure-free without any investigation. Probably some years ago, I think, performed the stereo G investigation in this patient. So now we can say we are probably not so far, at least in some patients, from a non-invasive, I would say, ESEI sourcectomy. Here you see. And again, also in this case, this is a drug-resistant epilepsy in a patient affected by tuberous sclerosis, and seizures were characterized, you see, by saccadic movements of the eyes, saccadic jerks. You see this eyes deviation. The patient was characterized, tuberous sclerosis characterized by the possibility to have within the brain different malformation, different tubers. Again, the patient was submitted to video EG recording, and we collected interictal and ictal activity. Interictal was clearly localized over the posterior right regions. Such activity was bilateral, but when performing again a source analysis using, in this case, high density, we were able to localize the origin of this activity clearly within a tuberous that was localized in the right occipital region. The patient was submitted to intervention, and she stops completely to have a seizure from these regions. She still has some rare seizure originated from another tuberous, but that are much more or less frequent than these ones. So electrical source imaging can be extremely useful in the presaggical evaluation for individuating the epileptogenic zone, but probably also can be useful for localizing some functional areas, some eloquent cortex. We can use also, for example, per analyze evoked potential activity, and can be something that we can compare, for example, with fMRI recordings. And in this case, performing an exam like this can be more easy for a child than performing an fMRI investigation within the MRI scan. So, as it has been shown in this paper from the group of Margita Sek, this is a population mainly composed by temporal lobe epileptic patients. You see that the sensitivity and specificity of ESEI is very high, especially for temporal lobe epileptic patients. It's a little bit lower. These are our data when consider extratemporal lobe epilepsy. However, still you have a very high percentage of subjects where we are able to localize the epileptogenic zone using high-density G and source imaging techniques applied to interictal spike. And especially the results also in our population are much better for those patients that are MRI negative. So if you have a patient with clear-cut epileptic discharges on the brain, MRI that is negative, probably there is underneath a focal cortical dysplasia, and ASI can be extremely useful in localizing the epileptogenic zone, in localizing the region, or at least in guiding the investigation with the investigation for with intracerebral electrodes, so can help guiding the plan of how to locate the intracerebral electrodes during the invasive investigation. And recently we have seen that we can detect with the high density G recording also fast oscillation more than 40 Hz. In generally, these oscillations are not so clearly distinguishable on the scalp due to the presence of artifacts. In this paper, we show that we can detect with a density G fast oscillation, and we can apply electrical source ESI to fast oscillation, and localizing fast oscillation is again extremely correlated with the location of the epileptogenic zone. Indeed, there are some experimental studies showing that fast oscillation are probably even more representative, more suggestive of the of pathological epileptic activity than spike per se, although the difference is not so extremely clear. Well, we can detect also HFO with high density G. Well, however, it happens, as I told you before, that sometimes, although we perform all the possible investigation, we are not able to localize the epileptogenic zone. So we are obliged to perform invasive investigation with the stereo EEG recording, for example. Stereo EEG recording is the practice of recording electroencephalographic signal via depth electrodes that are implanted, these electrodes, into the brain through small holes in the skull. And now with all the new techniques, we can really reach every region inside the brain. We can have different possible trajectories. And as you can see, with stereo EEG, we can go really to the deep of the brain structure, while with other methods, for example, grids and strips, in general, we can record mostly from the dorsolateral superficial area of the brain. So we cover large areas, but we don't have so much information related to the more deep cortical structures. This is the first method the Tyler rack frame features, so because the so-called proportional grid at the beginning, the introduction of the electrodes was performed using these grids, so you can clearly see that we have not so many trajectories that we can calculate, while now with the robotic system we can import into the software all the needed information from the vascularization, MRI, functional MRI, and DTI, and also source modeling within with the software in the stereo EEG workflow using the robot. And in this case, we can really have a strong accuracy, and we can reach both major and dorsolateral region of the brain with a very, very high accuracy. So we can really go close to less than about 1 millimeters, less than 1 millimeters of precision. So very, very accurate method now. And again, you probably are well aware of all this software. There are many others. This is what, in general, neurosurgeon, neurophysiologist, and then all our colleagues, mathematician and engineer, that work with us, they used to adopt sometimes this open source freeware softwares. And for example, in this case, we were able to improve our accuracy and also to reduce also the time to perform an exam, producing homemade software. And this was again a collaboration, for example, between the Milan Hospital, Niguarda Hospital, with the University of Milan, and also with the University of Genoa, in particular, Professor Gabriele Arnulfo, that I think will be also a speaker during this meeting. Here is just a picture to show you how much different can be the activity that we recorded inside the brain. Here, for example, we have a patient with a focal cortical dysplasia that is here at the level of the cingulate gyrus, and the right side of the cingulate gyrus probably is a small focal cortical dysplasia. And the electrode recording from this area, you see here, is showing a kind of continuous pathological activity with the spikes. However, scalp EEG recorded immediately over this region with all the EEG channel recorded from the vertex here. You see that scalp EEG is not able to detect spikes. So we have spike inside, probably less than 1 centimeters above, but we don't see so much on scalp. Then we should perform probably a quantify analysis, making an average on each spike in order to see that if there is something on the scalp, and this is something we are working on. So, however, when we use a stereo EEG recording, again, you have 108 channels, 108 lines of EEG lines. So, is again extremely useful to adopt quantify measures of stereo EEG data, because this, as it has been shown, can be notably useful for individuating, for example, high frequency discharges that are more close to the epileptogenic zone. So we can make analysis of connectivity. We can apply different quantify approaches in order to identify the functional and pathological network in a patient affected by focal epilepsy. So also when you are inside, we go back to the invasive, in this case, mathematics. So we can apply mathematics and quantify EEG analysis to help clinician in localizing the epileptogenic zone. And this can be done also using, for example, the response to single pulse electrical stimulation, because with the intracerebral electrodes you can send some stimulation, single pulse electrical stimulation, and then you can measure the evoked potential, you can make functional connectivity analysis, and all these analyses can be useful for individuate the seizure onset region. But for example, a protocol that we are now working on in collaboration also with Professor Sorrentino and the group from Genoa is try to extract much more information using this protocol that is a simultaneous recordings of high density G and stereo G recording. So the patient is dressing the high density G net while have also intracerebral electrode at the same time. I think this is it's a great opportunity. Try to optimize both the forward and inverse method. And for doing this, for example, we worked on evoked responsive to intracerebral electrical stimulation. And this, for example, is a first paper that we recently published, where we have data now are shared on, everyone can use this data, where we have the simultaneous registration of stereo G and scalp G. We have the stimuli induced by intracerebral stimulation. And here you can check for the better performance of one method with respect to the other one. You can even check if it's really so important to have 256 or 128 or 36 electrodes, and you can even check where is the which are the parameters that can be much more useful for localizing a spike originating from the mesial or the dorsolateral surface. So I think the possibility to have the co-registration is extremely useful to improve, and this is something we are still working on, as I told you, with the group of Professor Alberto Sorrentino. And then just to quote a couple of papers, but there are really hundreds of papers performed simply for research. Stereo G can be really an extremely fascinating instrument for making research, neurophysiological research. Here, for example, is a study that we have conducted together with the group of Professor Palva and so University of Helsinki and also University of Genoa, the Department of Engineering, showing that we can analyze, for example, the networks, the networks of coupling. I mean, applying techniques able to analyze cross-frequency phase synchrony or phase amplitude coupling. We were able to describe that this network have different anatomical structure, and this can be useful again for understanding much more the physiology of our brain. Like this one, a very recent paper again published together from, this is Gabriele Arnulfo and the group from Helsinki working on our data, on stereo G data, and they were able to show, for example, something that was not expected at all. So that there is a synchronization of high frequency oscillation, so with frequency higher than 100 Hertz, also within regions that are distant. So there is a long-range phase synchronization, while before we were thinking that these fast oscillations are mostly synchronized in a very local region, while infra-slow oscillations are more synchronized also in long distance. Here we were able to show that there is also a synchronization within high frequency activity for long distances, and such synchronization is particularly evident in some systems, for example, in the limbic system with other ones. We also were able to see that such a synchronization is different with respect to the more deep than the superficial layer of the cortex. I mean, using the electrodes, you can have one contact that in the deep part of the cortical mantle, and the second one that is more superficial. So we can analyze if such a long-range synchronization is more evident in the deeper or in the superficial layer, and here for the long distance was more evident for the deep structure. So it's really a physiological phenomenon. Also consider that we could increase such synchronization within the long distance at very high frequency activity after a go-no-go task, for example. So this is just to tell you that the work of neurophysiologists together with mathematicians, physicists, and neuroengineers is extremely important, both for understanding the patient per se. So it's a very relevant clinical role because help us every day in having new technologies. But then it can be extremely also useful for research, also for something that probably we will see the consequences at the clinical level in some years. So I thank you a lot for your attention, and sorry for not being really a mathematician in this group of experts. I hope this could be useful for you, however. Thank you very much.
Thank you to you, Lino. It was very, very super interesting. You gave a very important overview on the field.
Thank you, Annalisa. Thank you.
Is there some question? Okay, Karsten.
Karsten.
I unmute Karsten.
Yes, now I can speak, I think.
Okay.
Okay, thank you very much for this great overview talk. I have a question with regards, since I'm more on MEG and EG combinations, I'm very interested in the irritative zone, how it overlaps to the epileptogenic zone. What is your experience? How often does it make sense to localize interictal spikes, and how close is the localized irritative zone to the epileptogenic zone? So,
thank you, Karsten. This is a very, very important question, and that's why we need a clinician also managing all this exam. I mean, there are some conditions where interictal spikes, what you call could be more close to the irritative zone, is superimposed to the epileptogenic zone. I mean, if you have a focal cortical dysplasia, type 2 focal cortical dysplasia, in this case, you are sure that the interictal activity corresponds also to the ictal activity, to the same place, at the same level starts the interictal and also the ictal activity. The same can be, for example, for temporal lobe epilepsy. You can have interictal spikes that localize within the hippocampus. However, in this case, if you remove only the hippocampus, the patient cannot probably be seizure-free, because we know that it's not sufficient. The hippocampus, we need also some part, for example, the temporal lobe. So each time you have to consider the information that you have. So you are working on irritative spikes. I mean, you are interpreting irritative, so you have to consider which kind of patient I have in front. Is a patient where I suspect a focal cortical dysplasia type 2. In this case, the irritative is really close to the epileptogenic zone. Otherwise, you need more exam in order to really go to the target.
Thank you. This is also our experience. We have filtered out many type 2B
yes, exactly.
And
exactly.
Localizing the irritative zone always guided us to the epileptogenic zone up to now.
Yeah, indeed, if you find the dysplasia on the MRI, you can remove the dysplasia now. We are, well, you ask for question, but you don't need so much to perform so many exams. Unfortunately, the type 2 dysplasia sometimes is very small, and you don't see on MRI. No. Or you are not so convinced that these are alterations. So you need, in this case, ACI is fantastic.
So we have the same experience as you. We used source analysis to pre-localize, and then we tried with Zoom MRI. I don't know if you know this technique. So using multi-transmit coils to really zoom into that area with very high resolution.
Great. So we use 7 Tesla. We have a protocol where
it is not even 7 Tesla. It is 3 Tesla, but we have multiple transmit coils, so we can do zoom imaging, very high resolution, 0.5 millimeters.
This is great, Carsten. I will say immediately to our neuroradiologists, I was aware of something about that, but I don't think we have ever used this. And this changed a lot, but this what you do, Carsten, you apply a quantified method, or again is a visual analysis of the zoom, or you can make a superimposition right over the left, or
there are different opinions from the epileptologists I work with. So Jörg Wellmer is an MRI epileptologist, and he really loves to use the Münster Zoom-it sequence. While the Münster epileptologists, they often claim that you can see the same in FLAIR images. But my experience is that I think Jörg is more right, that in certain patients, it's really helpful to have additionally the Zoom-it.
Okay.
We published a paper in a single case study that I could send to you.
Thank you. Thank you.
That was a very, let's say, instructive study where the Zoom-it really helps.
Thank you.
Thank you very much.
Thanks a lot. There is a question on the chat. I try also to see Maria Carla.
Yes, so thanks a lot for your talk. Yes, I'm not sure I understood correctly something. From the graph that you were showing about the protocol, I understood that it is possible that an epileptic patient undergoes resection surgery without invasive investigation. So if you have enough hints from the non-invasive methods, it is possible not to implant the patient with ECOG or CEREG. Is it the case? And
well,
if so, how big is this percentage?
Fortunately, it's the majority. Fortunately, in the majority of patients, we can go directly to surgery without any invasive investigation. And we need the help of your skills to reduce more and more the number of invasive investigation. This is the main objective. Although with CEREG, then we can perform analysis of EEG that are extremely fascinating. From a clinical point of view, the main goal, the objective is not to put electrodes inside the brain, to use non-invasive mathematics and non-invasive investigation to localize inside the brain. This is the real final objective. But unfortunately, about 20% of patients, 25%, depending on the center, the percentage, they are submitted to stereo EEG recording. For example, 15 years ago, we submitted to stereo EEG recording some patients that now they go directly to intervention, because we know that when we have MRI, fMRI, and ASI that tell us this thing, we can go straight. And so we have more and more, much more difficult cases performing stereo EEG. So cases that before were immediately, I would say, discarded, to say, okay, there is nothing to do. Now we are trying to record with stereo EEG.
I see. Thanks a lot.
Thanks for the question. I think there is the last question. I don't know if Franca take you. Can you speak, Franca? I try to unmute, but no. Okay, can you speak now? We don't hear you.
Not yet?
Okay,
yes,
now yes.
Oh, so sorry. So thank you so much, Professor Nobili. It was really great to listen also from my side, that I'm not an expert in this field. And I liked to ask 3 core questions. One relates to the class 1 identification, is almost straightforward. It refers to the consistency of all the aspects and how much is focal the focus.
Class 1 You mean the class 1 is the way
those
of
that are very suitable for surgery?
No. Class 1 is mean those that are seizure-free after surgery. It means that we have 80% of subjects submitted to
So it's defined afterwards.
Afterwards. So
But,
afterwards.
Okay, but you have a lot of science that allows you to predict who will be.
Yeah, that's
one.
The study is we have many research paper, many clinical papers showing what is good in this kind of approach is that we have the gold standard. So the patient can be seizure-free or not. So
no, I understand, but this is defined afterwards.
And then before you can measure on the basis of state, which is the sensibility of one method with respect to the other one. But
sure.
If we don't have the seizure outcome, we cannot be sure always. Fortunately, we have many patients.
So I well understand that this is defined afterwards, after surgery, but evidently is very relevant to predict before those, obviously.
Yes, this is something that's related to your experience. And when we speak with patients, we say, in this case, in our experience, you have a probability to be seizure-free, a probability that is higher than 70%. You say something like that, but you really, then, you know, every patient is different from the other. So you speak with, in general. But when you propose an intervention, is because you have a probability to be seizure-free that is extremely higher with respect to the possible, I'd say, side effects or complications.
Sure, and the second relates to also the data you showed that if you intervene quickly, you obtain a very good result, and this can be even worse if you wait intervening. In this respect, what is your feeling in using the atlas that are built either in MNI and now in Niguarda about recordings in healthy areas? This aspect that you find science so persistent even when you remove the altered zone. Do you feel that says something about the use of intracellular recordings and as healthy regions for electrophysiological investigations?
Well, indeed, there are many groups. For example, in Montreal, Birgit Frausch is producing the atlas of physiological activity, and to see how this activity can evolve within your life. So I think this for sure is important. The main message is that before you perform surgery, before you have the possibility to have less complication because of plasticity of the brain of the child that is much more higher than the plasticity of an old, consider that for a surgical intervention when you are 40 is you are a little bit old. You are very old. So and then so you have less complication, but also you have more possibility to be seizure free because the region, the epileptic zone can be sometimes very small, but then if you wait too much, for example, for epilepsy involving the hippocampus, then the epileptogenic zone can be very large. So you have to remove much more area, and you are not sure also to obtain a seizure-free outcome. So before you perform epilepsy surgery, before you are able to do this, less complication and much more results in terms of outcome.
The very last question, have you an impression about open source with respect to commercial softwares that have an advantage one with respect to the others?
Sorry?
If you have the feeling that open source softwares are better or not than with respect to commercial ones?
Well, I have to say, when I started doing electrical source emission, I bought a software. I paid the software a lot. It's fantastic software. But I have to say that then when I used with other my colleagues open source and software or at home built-made software, they are working very similarly. So I'm very a fan of open source algorithms and so on.
Me too.
In fact, this is my colleagues with whom we are working with are very interested in this line of proceeding, because it is probably the right tool to integrate advances in a more straightforward way, although probably they are less standardized when used. Thank you so much.
Thank you to you.
Franca, thanks a lot, Lino, again for your interesting talk. Thanks.